Hello, welcome back to another homework video. So this homework we're going to be talking about dimensionless groups, dimensionless numbers, and in this one specifically we're going to look at a dimensional matrix and determining the null space as well. So looking at this pipe, we're going to look at the flow through the pipe and what can influence the flow. So for this is going to be a change in pressure from one end of the pipe to the other. It can also be determined by the velocity of the flow, as well as the viscosity of the fluid, and also the density of the fluid that's flowing through the pipe. Another factor would be the dimensions of the pipe itself, which is going to be the length and the diameter. So these 6 components all influence the flow through the pipe, and that's what we're going to look at for a dimensional matrix. So to make this matrix, we are going to have at the top here, this is going to be the length, diameter, velocity, viscosity, density, and the change in pressure. And all of these variables are going to be related based on their mass, length, and time. And we can say these units are kilograms, meters, and seconds. So this is how we're relating all of them together. So let's write out the units for all of these dimensions. So the length and the diameter are both going to be in meters. The velocity is meters per second. The density is kilograms per meters cubed. And then viscosity is in kilograms per second times meters. And the change in pressure, or just pressure, is going to be in kilograms per second squared times meters. So we can use these to plug them into the matrix. So for the length going this way, there's no kilograms, no seconds, and meters is just one of those. Same thing here. For velocity, the meters is in the numerator and seconds in the denominator, so that's going to be a -1. And there's no kilograms in the units. Viscosity, there's kilograms in the numerator, and then seconds and meters are in the denominator, so that's a -1. For density, kilograms in the numerator, and the denominator is meters, so it's negative, and 3 is because meters is to the 3rd power, and this has no relation to time. And then for the change in pressure, we have kilograms in the numerator, meters in the denominator, so that's -1, and then the seconds in the denominator to the 2nd power, so that's -2. So here's the matrix for this scenario. Okay, so this we said was the matrix for the flow through the pipe. So I'll move it down here. And to get the dimensionless numbers, that's the goal that we want. We want to multiply this matrix as something to get, or by another matrix, to have all these units of like kilograms, meters, and seconds. We want all of these to be 0 because there's no units in a dimensionless number. So to do this, we want to multiply by the different vectors in the null space. So this will be these C values to get this dimensionless group. So the null space is going to be a vector with 6 dimensions. Write this down here. And the 6 dimensions are these 6 up here. And for the null space, we're just going to take the dot product of this vector times the vector of the null space to get these values to be 0. That way we can form dimensionless groups. And the dimensionless groups just helps us relate all of these dimensions together. So first, let's look at Buckingham Pi method. So for this, we have 3 equations. And we have 6 variables. So for Buckingham Pi, we want to constrain this so that one of the variables is to the first power. This is like to completely simplify it. So we have 3 equations. This is going to be pi 1, pi 2, and pi 3. And we have 3 equations, so we want to constrain 3 of the variables. So for this one, let's constrain the length, the viscosity, and the change in pressure. And then for these 2 variables, instead of raising it to the first power for these, I'm going to put it to the power of 0. That way we can actually solve for a dimensionless number at the end. Okay, so here's what this is going to look like. So we have length to the first power. We have the viscosity raised to 0, and the pressure also raised to 0. So if we look back at our variables, we have the diameter is raised to some power, the density is raised to some power, and the velocity. So do this. So these 3 variables, these are the ones that we constrained. And that means that A, B, and C, whatever these values are, they have to adapt to this constrained, or the constraints that we implemented. That way this pi 1 becomes a dimensionless number, to have all the dimensions cancel out to be 0, like we set up here. So now we can write in the other pi equations. This is going to be the length to the 0 power this time. Let's do the viscosity to 0 again. This time let's do delta P to the first power. And then this is all going to be have to change again, so we can actually write this as let's do, I'll do these in different colors, that way it's easier to tell. But these are going to be different for each equation that we have. It's dependent on which variables, or how we constrain the variables at the beginning here. So here's our 3 equations for the Buckingham Pi method. So now I'm going to go over to Python to show how we can actually use the null space to get these dimensionless numbers. Okay, so to start off with this code, let's import numpy as np and import scipy as sp. Okay, so now we're going to make our matrix from earlier. So this is going to be np.array Okay, so going across, we had length, diameter, velocity, viscosity, density, and pressure. So for the first row, that was in kilograms. So we had 0, 0, 0, 1, 1, 1. And then the second row was in meters. That was 1, 1, 1, -1, -3, and -1. And then the last row was in seconds. That was 0, 0, -1, -1, 0, -2. And then, because it's the end of the array, we put a period here. And let's make sure we're good. Perfect. Alright, so now the array is finished. Okay, and then this array, that's what it looks like. And now we want to calculate the null space for it. So let's say null space. This is going to be SP. We're going to be using linear algebra, so that's then linear algebra, null space, and we're trying to find the null space of our matrix that we made. Cool, so that works. And the null space, there it is. So these values here satisfy the dot product to get us our dimensionless numbers, which is the goal of like the Buckingham Pi as well. So if you remember from earlier, we were multiplying the matrix by some coefficients, the C1, C2, and C3 values, to get the dimensionless numbers. So that's what we're going to try to solve for now. Okay, so to solve for C1, I'm going to say that's equal to numpy. We're going to use linear algebra again to solve. This is going to be the null space, and we are going to look at the variables from before that we had pulled out. We said that was the length, viscosity, and the change in pressure. So in our matrix, that's going to be the first column, which is going to be 0, the third column, and the fifth. And we want the null space to be for, like to go through each row. So that's why there's a colon there as well. And then looking at the array, we want to constrain the variables. So we want the length, which is in column, in column 0, which is the first one. That's going to be, we said that was to the first power, and then we had the viscosity and pressure to the 0. And perfect. Okay, that works. So that's the equation for C1. So let's see what C1 gives us. Okay, cool. So we have this new array, and so we can multiply these numbers by this matrix to get our dimensionless numbers. So now we want to take, oops, not there. Okay, now we want to take the dot product of the null space and C1. Okay, so we get these values here. So looking back at our pi equations, this was using the first equation that we set up. So these values are going to be like what we're raising each of the variables to, like what power we are raising them to. So this is going to give us, we said that the first column, we said that was length, and this would be raised to this here. That's just going to be to the first power. The next column we said was diameter, and that's to the -1, so that means that diameter is going to be in the denominator. And then the rest of these values are basically too small that we're just going to say that they're raised to the 0. They're not exactly 0, but they're pretty close. So this first dimensionless number that we have is just length over diameter, and that's just going to be meters over meters, which cancels out, so that's the dimensionless group that we have for the first pi equation that we set up earlier. Okay, so now let's do C2. It's going to be the same setup here for C2, but instead, going back to our pi equations, we had length to the 0 power. The viscosity was still to 0, and we put pressure to the first power this time. Cool. And then, oops, here's that array. And then, same thing as last time, you want to do the null space. I'm going to take the dot product between the null space, and this time it's going to be C2. There's our array. Great. And this is going to be for our second pi equation. Okay, so we're going to have, we had the length is in the first column, so this is close to 0. Same thing with the diameter, so we can exclude those. We have the velocity, which is to the negative second power. That's going to be in the denominator. V squared, okay. And then viscosity is close enough to 0. We can keep that out. This is the density to the negative first power. So this is rho. Oh, do this. Hopefully that's easier to tell. And then this is going to be pressure is in the numerator. So that's the dimensionless group, or dimensionless number rather, for C2, which is going to be the second pi equation. And then I'm going to do the same thing to solve for C3, because we have 3 equations. There we go. This is C3. And for C3, we put viscosity to the first power. Great. That's that array. Again, taking the dot product between the null space, and this time C3. There we go. So for the third pi equation, we have that the length is raised to the 0 power. We have the diameter is going to be in the denominator. Oh my goodness. There. And then velocity is also in the denominator. We have viscosity, which was mu. We have that in the numerator. And the density is in the denominator. And then again, this is going to be too small to put pressure in this equation, but viscosity over density times the diameter times velocity. This is going to be the same as the inverse of the Reynolds number, but that's that dimensionless number for C3. Okay, so that's how you use the null space to solve for dimensionless numbers, and we did that here in Python doing like an automated version of Buckingham Pi method.